Okay, we're going to talk about the binomial theorem, which is really an interesting little theorem and pretty useful too. So first of all, a binomial is a polynomial with two terms, x plus y, a plus b, 3x plus 7z, whatever. And when you raise them to a power, we have a quick way of expanding them, the binomial theorem. And so, of course, when anything is raised to the 0 power, it equals 1. And if I square a binomial, I get 1x squared plus 2xy plus y squared. If I cube it, I get this. If I raise it to the fourth, I get this. So what happens if we raise it to higher powers? Well, the binomial theorem lets us figure out what happens quickly. But before we move on to that, let's look at some patterns. Notice that the exponents of every term add up to the original power. 2, 1 plus 1, and 2. Here's 3. 2 plus 1, 1 plus 2, they all add up to 3. 4, 3 and 1, 2 and 2, 1 and 3, they all add up to the original power. So once we see that pattern, it'll help you understand the binomial theorem. Okay, here it is. In the expansion of x plus y to the n power, where it equals x to the n plus n, x to the n minus 1y, plus, dot, 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 and then this is n combination r, x raised to the n minus r power, y to the r, plus blah, 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 all the way out to y to the n. Now, don't worry about that, okay? There's a pattern that makes you use the binomial theorem very easily and quickly. But you may be asking yourself, what the heck is that right there? Okay, that is, if you have a combination of n, r, that's n factorial over n minus r factorial, r factorial. And a quick way to write that is just parentheses n over r. Okay, remember that equals n factorial over n minus r factorial, r factorial. So let's do it with numbers, okay? So if we need to find the combination of 8 over 3, that's going to be 8 factorial over 8 minus 3 factorial times 3 factorial. And remember that factorial means that's 1 times 2 times 3 times 4 times 5 times 6 times 7 times 8. And that's going to be 5 factorial. 1 times 2 times 3 times 4 times 5. And then that's 3 factorial. Times 1 times 2 times 3. Well, I can cancel the 1 times the 5 on the top and the bottom. The 6 cancels out the 1 times 2 times 3. And all of this reduces to 56, 7 times 8. Okay, so that's how you can evaluate a combination. Now you can also do it on your calculator. So let me bring this in here. So if I want to do 8 combination 3, then I do 8, and then I do math, arrow over to PRB for probability, and there's number 3. And then I hit 3. And we get 56. So that's a quick way to evaluate a combination on your calculator. Okay. Now, let's talk about a really cool mathematical object called Pascal's triangle. And here's how it works. The first row is 1. The second row is a 1 and another 1. And every row will start and end with a 1. This is going to have a 2 in the middle. Start with a 1, end with a 1, then I'm going to do 3 and 3. How the heck am I getting these numbers? Well, to get these numbers in the middle, I add together the 2 that are above it. 1 plus 1 is 2. 1 plus 2 gives me 3. 2 plus 1 gives me 3. 1 plus 3 gives me 4. 3 plus 3 gives me 6. 3 plus 1 gives me 4. Once you know the trick, it's really easy to generate as many rows of Pascal's triangle as you want. Okay, and there's all kinds of patterns in here. For example, 1 is 1 if I add it up. 1 plus 1 is 2. 1 plus 2 plus 1 is 4. That works out to 8. 16. Do you see the pattern? That's 2 to the 0, 2 to the first, 2 squared, 2 cubed, 2 to the fourth. This one will be 2 to the fifth, which is 32. and so on. Okay, these numbers give us the coefficients of our binomial expansion. So if I want to use Pascal's triangle to expand x plus y to the fifth, here's what I do. I go to the fifth row of Pascal's triangle. And how do I know I'm at the fifth row? When my second number is a 5. So these are the numbers that I want to use to expand that binomial. And what about the exponents? Well, the exponents of the first term will start at 5 and count down, while the exponents of the second term will start at 0 and count up. So here we go. 1x to the fifth, y to the 0, plus 5x to the fourth, y to the first, plus 10 x cubed y squared plus 10 x squared y cubed plus 5 x y to the fourth plus 1 x to the 0 y to the fifth. So you see, I got all my coefficients straight off of Pascal's triangle. Well, what happens if I have something besides just a simple x or a y or an a or a b? Same rules apply. We're going to go to the third row. So it's this row here because 3 is our second number. I'm going to go 2x to the third plus 3 times 2x squared times negative 3, because negative 3 is my second term, plus 3, 2x to the first, negative 3 squared, plus my second term to the third. And when I work all that out, that's going to be 8x cubed. Now here I have negative 3 times 2 squared. So it's going to be negative 20, let's see, that's negative 9 times 4 is negative 36x squared. Here my negative 3 is squared, so it's positive, so it's going to be 9 times 6, that's 54x, and then finally negative 3 cubed is minus 27. That's a lot easier than multiplying that out 3 times using FOIL. Okay, last example. What if I just want to find one term? For example, find the 7th term of a plus 2b to the 10th. Okay, well, let's go back up to these expansions and look at some patterns here, okay? Notice that the exponent of y is always 1 less than its place in the expansion. Y to the 0 is in the first term, y to the first is in the second, y to the squared is in the third term, y cubed is in the fourth term, and y to the fourth is in the fifth term. So remembering that, if I want to find the 7th term of this, that means I want the second term to have 1 less than 7. So it's going to be raised to the 6th power. And since the exponents have to add up to 10, that means that the first term has to be a 4. Okay, what about the coefficient? Well, the coefficient is going to be the combination of n and r. So we're going to get 10 factorial over 10 minus 6 factorial, 6 factorial, a to the 4th times 2b to the 6th. And we can work that out in our calculator. So 10 combination 6 is going to be 10 math over to probability. Grab our combination, and we're going to put in 6. Okay, so that's going to be 210, a to the 4th, and 2 to the 6th is 64, b to the 6th. Let's multiply out 210 times 64, and we get 13,440. That's our coefficient for that expansion. A to the 4th, b to the 6th. That is the 7th term of a plus 2b raised to the 10th power.